that says, okay, I can allow all this different kinds of images and blah, blah, blah from myself. I shouldn't have said images, everything other than images. Images I'm going to get from anywhere. I'm only going to load objects from media 1 and media 2, and from my content distribution network, I'm going to only load scripts from here. Yes?
If you have a complex web application with a complex HTML handling, and you happen to forget on one particular page or directory to include this header, you're screwed. Is it so?
Yeah.
Okay.
Yeah. The policy's emitted with every page instance, and it only applies to that instance. Now, since more and more web applications are client-side, there are a huge amount of JavaScript comes back. Gmail is an example. So basically what we're dealing with is mobile code. And you would get one content security policy emitted with that, and then it sits there and does XML, HTTP request connections back to the server, and it's like you just installed a local application. But that policy would just sit there because the page never reloads or doesn't for a long time. And so CSP needs to be strong enough to handle that kind of use case. Now, it only works sort of good. This is all experimental, right? This is not guaranteed to work today. It's an ongoing experiment. There's a paper that will be presented at a conference, I think in May, I'm not sure, but that's what I think. I've read the paper, it got shared with me, and some grad students worked on applying CSP to a non-trivial web application, like Bugzilla. And they researched how much work they had to do because you have to change your application to make CSP applicable. Like if you use inline scripts a lot, well, inline scripts are one of the vectors for cross-site scripting. If you want to be secure against cross-site scripting, you probably shouldn't use inline scripts. But then you have to make all these connections back to the site to suck your scripts over, which is more round trips, more GET requests, and there's a performance impact. So you have to rewrite your app, and then you have runtime performance impact. So they studied this, and there's some issues. Okay, so we need to go back to the drawing board and see what we can do about that. So, real-world problems, which we've been sort of talking about as we've been going along. We can talk about framing, making cookies secure, and HTTPS only. This is somewhat redundant because we've already been discussing it. Framing is difficult. I can give you these slides are already on the web, so I can give you the URL to them. This is the frame busting paper. The other thing with all this is the world is a moving target. X-frame options is only supported in recent browsers. It's not supported in old ones, and there's a huge number of the people out there on the planet still using old browsers. So you can try to protect yourself as a web application, but it's not going to be terribly uniform. And if your users are using Firefox 4, you can use content security policy. So this is the secure thing. This is a, if you're setting a cookie, this is a response. That's the set cookie header. So this cookie is not secure because it doesn't have those two flags, HTTP only and secure. So you want your cookies, you want them to look like that to at least be somewhat secure. But there's no standard approach There's not a switch you can throw that will just magically make this happen necessarily. So web application firewalls and servlet filters can kind of help. Those are things that modify, you can generically modify your page instances as they get emitted towards the browser. And if you're using Apache, then you can use mod security to craft a rule set that checks for cookies lacking these and applies them. And this is a pointer to the article about how to do that. It's non-trivial. It's a fair amount of code. It's a really complicated rule set. And it's a little different depending on how your pages are constructed. It's going to be different. Different apps, it's going to be different. So what we're trying to say is all this junk is too hard to do. So you can make your entire site HTTPS only like we've been talking about. You have to convert all your links. You have to beware of content served from other people, such as images, analytics, and stuff. You ought to make sure you redirect when you do if you redirect from the HTTP version of the site to the secure one, which is a common thing to do, we do it. You should use a 301 redirect, which is a permanent change for search engine optimization issues. If you do the temporary redirect, it affects your page ranking, or it can. Of course, this is all hand waving to some degree. And so to make the entire website, then you should also emit strict transport security policy. So we've got a ways to go. So up at the beginning, we had the list of things you couldn't do safely. Well, you still can't in some cases. Even with all this help that we've talked about. So there's some constraints. There's not a general purpose security policy framework or mechanisms. You can't easily, even with the prior stuff today, safely include third-party content. You got this attack surface problem. You can't embed third-party script, not safely anyway. Not all deployed browsers implement the new security stuff. So your users, there's a broad continuum of browsers. Still people out there using Firefox 2 and IE6. So we should have some goals, and these are our goals. For a site that has developers and the site operators, you shouldn't rely on the developers getting it 100% right all the time. It just doesn't scale. We should have security mechanisms where you can declare policy that are easily, and that the policy is separate from the code. You're not encoding the policy directly in the implementation of the site. We're inventing new HTTP headers all the time. I'm not sure this is such a good thing to do. We talked a lot about this at IETF last week. There's issues. It's going to be hard to do that, but we might be able to reduce the need for new headers. People like Google and Yahoo and us are concerned about the number of bytes we're emitting in headers. So like strict transport security, it's all spelled out, it looks nice on slides, but it's chewing up a lot of bytes unnecessarily. One could argue that we should really have a very short name for it, for the header at least. And what we'd like to do overall is create security mechanisms that allow and enforce the concept of least privilege. In other words, you only need to give an object or an entity just enough privilege, just enough to get their job done and no more. So how do we get started? Terms and definitions. A huge amount of stuff in the web world is folklore. It's like written in blog posts, if it's written down at all. Like the notion of origin was just cooked up out of thin air by somebody and never really specified. What's a site? I'm starting to think, trying to talk about web applications, because they're not just documents, they're not static documents. I believe HTML is a programming language. It's a declarative programming language. You can go look that up. There's formal papers. What's a declarative programming language? What's an interpreted one? And HTML is a declarative programming language. We need to realize that what we're dealing with is mobile code, because it affects how we think about the security problem. We think we need to have some form of web security policy framework, and we need to get that designed, and we need to have coherent notions of what that means, and we need to figure out where to have the discussion and make this happen. So there is some work in progress. The IETF WebSec working group, which I helped get started, and that's where we're working on strict transport security. There's a draft about a web security framework requirements that I recently put together. It's very rough. We need to keep working on that. The W3C web apps security and web apps working groups, there's work going on there. We're looking for a chair for web app security in case anybody has some free time. And a related working group in the IETF is the DANE working group, which DANE, the name, I don't really like the name, but what it stands for is DNS-based authentication of named entities. The work was originally called Keys in DNS, and the mailing list, which is going to change, is called Key Assured. The notion there is DNSSEC is a reality. Your guys have actually worked a lot on it, Andre Suri and company. And I don't know if you saw the announcement, but the .com domain is now signed. So everybody in .com, at least the keys are there in the DNS, and now the registrars in the registry, well, VeriSign's done the work at the registry level. Now the registrars need to do some work in order to be able to convey individual domains, keys, upward, and put the machinery in place to make that happen. But the hard work at VeriSign is now done, which is great. So what we're working on in the DANE working group is leveraging DNSSEC for TLS connection establishment in terms of the trust. So if we jam certificates and or keys into the DNS, and that's signed and secure, then when you establish a TLS connection and the server says, oh, here's my key, trust me,